Hello, this is Jim with We Develop Electrical Products. Today we discuss how we upgrade last week's project on making the Arduino cause LEDs to dance to music. Stay tuned to see how you can make these upgrades. Enjoy the Arduino.
Hello, this is Jim with We Develop Electrical Products. Today we're going to be talking about our 17th project. It's an expansion of our 16th project, which was making LEDs dance to music. And what we did on that project is we had a couple of wires. One wire was coming out of the A0, another wire was coming out of ground, and we just connected those two wires to the audio output of our computer. And what that does is if you look at the signal level, what we're reading at A0 in the Arduino is we're going from ground, this 0 value, and this is a digital value representing the voltage coming out of our computer, and it swings from 0 to a high level, and it can go up to 1023. All the way up to 5 volts if we have the voltage or the volume maxed out. So you can see that we're getting a swing from ground up to a value here of 120, and as the music progresses. What we'd like to see when you see an audio output from a computer, you also have a negative swing. It's not chopped running down here. So what we did is we found a way to get both the positive and the negative swing from our audio. And the way we did that is we hooked up two resistors in series here, both 100k ohm resistors. And we tied one of them to 5 volts from the Arduino, and then connected that to another resistor and tied that one to ground. So we have two resistors in series, both 100k ohm. So it's taking that 5 volts from the Arduino and splitting it in half right here at this point, or 2.5 volts. And then we take that 2.5 volt DC signal and run that back around to our A0 line in the Arduino. And so we're pumping in a 2.5 volt DC signal to A0 constantly. And then we AC couple using this 10 microfarad capacitor our audio input, or the audio output from our computer, and we DC couple that in, or AC couple that into A0. So we're going to have an analog or a AC signal on top of this DC 2.5 volt signal. So that's how we changed it to get that. This 500 represents the 2.5 volt DC level. And then the AC level is swinging around that 2.5 volt level. Another thing we did is we just went out to a Walmart or whatever, wherever you buy electronic parts, and we got a 3.5 millimeter Y cable, one male to two female Y cable. So we can plug that into our audio output of the computer, and then we can plug our audio or our 3.5 millimeter male jack into the female, and then we're putting a powered computer speaker into the other one so that we can hear the music. So that's basically what we did differently in this circuit, so that we can see both the positive and the negative swing of our audio input to the Arduino. The LEDs are hooked up the same way they were in project number 16. As always, the LEDs have a polarity to them. The long lead is the positive lead, so that's the one that hooks up to the resistor. And the short lead is the negative lead, so that's the one that hooks up to ground of the Arduino. And like in all projects, links to this schematic and our sketch, the Arduino sketch that we're going to be using, this program, and links to previous videos and links to where you can buy these components are all in the description below. And so if you need to get more information on how to hook this up, you just go to those links and you can find this schematic. So that's basically how the schematic changed. Now the sketch, what we did differently in the sketch. We did a couple of things in the sketch. One thing you have to do, which we went over in video 16, is you have to go to GitHub, because we're going to be using statistics for this. And you have to download a statistics library from GitHub, and this the statistics library on GitHub will be in the description below as well. So you go to this link and you click on clone download and click on the download zip folder, and you download this zip folder, and then you go to your Arduino IDE program, and you go to sketch and include library, and when you go to the include library, then you go to add zip library, and you add that library to the IDE. And then you can scroll down once it's added, and you can click on the statistics-master, and that'll install then the library, which is what this is. This include statistics H, integer statistics H, and include statistics H. And then you can write these other programs or other parts of the program. So we're going to have what we did differently. I went over this in video 10. But what we did differently on this one is we're still using statistics like we did in project 10. But now we're also assigning a long of start timing and an unsigned long of timing count. We're going to be using those to determine whether or not a new song is playing. And then we've got an integer of delay time of 100. That delay time is used for how long the LED is going to be turned on once we've determined which one to turn on. And then we've got the statistics stats, which is part of the statistics library. And what that does is it's saying that we're going to collect 100 values of this microphone input. In other words, A0, we're going to sample A0 100 times. And once we've sampled that 100 times, we're going to determine the mean, the standard deviation, the max, and the min. And then we got down here in the loop, and we're just doing a lot of pin modes of setting outputs for all of our LEDs. And then we're doing some digital writes to turn all the LEDs off by setting them low signals. And then in our stats library, we've got this stats.reset, which what that does is it resets that matrix of 100 collections that we've made. It resets them all to 0 to start all over again. Now down here in the loop, one thing we've done differently here, I said we're going to be determining whether a new song is playing or not. So in order to do that, we do just like we did in project number 16. We do an analog read of the microphone input, that A0 line, and we put that in a variable sound level. And then we do some statistics on that sound level to determine the mean, the standard deviation, the max, and the min. And then we set our start timing to this variable, or to this millisecond. And what that is it's setting it to the amount of milliseconds that the computer program has been running. We do that same with the timing count. And then we dropped a while statement here, and we determine whether the sound level is less than or equal to 520 and the sound level is greater than or equal to 500. What we're trying to determine here is if there's no song playing. If we go back to our signal level here, we're saying 500 is just the DC voltage, and we're saying we're going to allow it to go from 500 to 520. If there's no swing greater than that, we're going to say that there's no song playing. And if there's no song playing, we drop down here and we do an if statement. And it says if timing count minus start timing is greater than or equal to 1,000 milliseconds or 1 second. In other words, if we haven't been playing a song for 1 second, then we reset the statistics. And then we drop down into these if statements. So what these if statements are is we're trying to determine when to turn a LED on. If we look back here, we've got a lot of different data points here, and we're trying to determine where in this swing we're going to turn LED 1 on, and 2 and 3 and 4, and that type of thing. The way we're going to do that is we're going to look at a bell curve, and this bell curve isn't drawn perfectly, but the data points that we're collecting will end up in a bell curve like this. We're going to have 8 sections. I only got 1, 2, 3, 4, 5, 6, 7, 8 sections, but and we're going to determine where to turn LED 1 on, 2 on, 3 on, and 4 on. If we look back at our script or our sketch, LED 1 is the one we're going to deal with first. And we're going to say, is the sound level greater than or equal to the mean? In other words, if we go back to our bell curve, we're going to ask, this is the mean here, is it greater than or equal to that point right there, that line? If it's this direction of that, and that's what these two things are, and the sound level is less than or equal to the mean plus 3/8 of a standard deviation. In other words, looking back at the bell curve again, if it's greater than this and less than this line, if it's in between these two, then we're going to turn the LED on, LED number 1 on. And then they've also got an or statement here, or if the sound level is greater than or equal to the mean minus 3/8 of a standard deviation, and the sound level is less than or equal to the mean. In other words, going back here again, if we're also in this section, we're also going to turn LED number 1 on. So if it's anywhere from this point to this point, we're going to turn LED number 1 on. And the way we turn LED 1 on is we just drop down in here. If the statement is true that we're in between those two lines, then we do a digital write of LED 1 and make it a high. And then we do a control RGB. This is a function we create, and we pass to that a 0, 0, and a 255. And if we go down here to this function of control RGB, we do an analog write of the red LED, and we pass that a value of 0. So that keeps it to an off state. We do an analog write of the green value, and we pass that a 0. So that leaves that one off. And then we do an analog write of the blue, and the blue value was 255, so we turn the blue on. And then we go back up here again, and we delay for the delay time, and that delay time was set to 100 milliseconds. And so after a delay time of 100 milliseconds, we drop down here, we do a digital write of LED 1 low, so we turn LED 1 off. Then we drop down here to the function of control RGB again, and we pass them all zeros, so we turn all 3 of those colors off. So that's how we're determining whether to turn LED 1 on. And then we're doing an if statement here on LED 2 of the sound level being greater than or equal to the mean, being 3/8 of a standard deviation, and the sound level being less than or equal to the mean plus 3/4 of a standard deviation. So if we go back here to our bell curve again. Now we're asking, is it between this line and this line? If it is, we turn that LED on, LED 2. And then we're also saying, or if it's the sound level is greater than or equal to the mean minus 3/4 of a standard deviation, and the sound level is less than the mean minus 3/8 of a standard deviation. In other words, if we go back here again, if we're in between these two lines, we turn LED 2 on. So in other words, if we're between these two lines or these two lines, we turn LED 2 on. So basically we've got 8 if statements to determine which section of that bell curve we're in to turn those on or off. And then we've got this analog write, or this RGB function down here. Now I've just got this serial print line of the sound level, and that just gave me these plots that you're seeing here using the serial plotter. So now I'll show you how this works in real life. And see.
So this is it in function. So if you like this video, please hit the like button, subscribe to the video, and share the video. So enjoy the Arduino.